So a lot to review for this exam. We're going to cover stuff from 8.1 to 9.2. I'm just going to hit the highlights. I'm going to go kind of fast because there is such a lot to review. You should be able to find a copy of this on D2L. So the reason I chose this one is I wanted to remind you something when we're solving inequalities. And if I add 3 to both sides, I end up with something like this. To finish this up, I've got to divide both sides by -6. But what happens in an inequality when I divide both sides or multiply both sides by a negative number? What? You remember?
You have to change the direction.
Yeah, perfectly. It changes the direction of the inequality. So this is going to be x is greater than or equal to -2. Graphically speaking, let's take a look at the graph. If the variable is on the left-hand side, what have I always said about these inequalities? If the variable is on the left-hand side, then graphing it
goes the way that the inequality is facing.
Yeah, you're gonna graph this the way that the inequality is facing. So I want everything greater than or equal to -2, so that puts a solid dot here. In terms of interval notation, and quite often you should be asked for interval notation. The left-hand endpoint is 2, the right-hand endpoint is infinity, which always gets a parenthesis. But am I going to use a parenthesis or bracket here on -2?
Bracket.
Bracket. Well done. Now, let's go up to this one over here. This one's got, let's see, this one's got decimals, and that's kind of annoying / frustrating. So what I would suggest is that you multiply both sides of this inequality by something to get rid of the decimals. What would that be? Can anyone think of that? What would move the decimal 1 spot to the right?
10.
10. Perfect. So if I multiply everything by 10, then it's going to give me 9x plus 7 is less than or equal to x plus 19. Let's see. I'll subtract x from both sides and get 8x plus 7 is less than or equal to 19. 8x is less than or equal to 12. X is less than or equal to 12 over 8. Now in WebAssign, you don't necessarily need to put this in lowest terms, but for me, I think I'd probably prefer that you write it as 3 over 2. I don't care if you write it as 1.5, but I would like to see it in lowest terms. So as far as the graph is concerned, 1.5, solid dot, arrow to the left. This time our interval would be -infinity to, you know, I like improper fractions better, 3/2 like that. So how's that one looking? Looking okay there? All right.
Yeah. I have a question.
Yeah, please go ahead.
Is the test going to be like a paper test, or are we doing it on our computers in class?
No, it's going to be a paper test.
Okay.
So yeah, do expect a paper test. And I'm giving you lots of great problems right here. So let's keep going here. Let's see, where's this one? Exam review. All right, let me scroll up to the top a little bit. Oh yeah, I almost forgot this one. These two actually. So solve this equation. You know, kind of a little theme in the first couple of these problems would be that, let's see, what was x over, is that they both have fractions or decimals. You need to play with them to kind of whip them into shape. And the trick is to multiply both sides by the lowest common denominator. But where people make a mistake on this is they forget that they need to multiply both sides by that lowest common denominator. First things first, what's the LCD here? What's the lowest common denominator? Yeah, 6. So I'm going to multiply by 6 here and 6 here. this gets multiplied by 6, even though there's nothing to cancel. On the left-hand side, 6 has to multiply this one, and it has to multiply this one. So you know what? I'm just going to do this. I'm going to multiply everything by 6. It may help you on the left-hand side to think of this as 6 over 1. On the right-hand side, I'm not going to get any cancellation, so I'm just going to ignore that. I'm not going to write 6 over 1 here. But on the left-hand side, I do get some cancellation. 3 cancels into 6 twice, leaving me with 2x. 2 cancels into 6 3 times. So you end up with minus x. Yeah. Minus x equals 18. Divide both sides by -1, x equals -18. Beautiful. So again, some more practice with multiplying both sides and clearing out decimals or fractions. Okay, let's keep going. Kind of a short one. Not sure I'll put one on the exam like this or not, but I'll give you a quick glance at it anyways. And it's kind of the last of the first barrage of problems dealing with fractions. In this case, they asked you to solve for, what was it? It was H, B, solve for B. So I want to get capital B by itself. What I suggest in this one, and what I suggest in all your problems that have decimals and fractions, is that you clean them up. So in this case, I would multiply both sides by 3. So that gives me 3 times V. But what happens when I multiply the 3 by the 1/3? They cancel. And now I want to get capital B by itself. To do that, I got to get rid of the H. Since H is multiplying B, the opposite of multiplication is division. So I can just divide both sides by H. 3V over H equals capital B. Beautiful. Okay. How's that one look? Doing all right there? Cool. Well, let's keep going then. You should be able to graph a polynomial, or excuse me, not a polynomial, a line. Now, there's a couple ways you can do this. One is you can plot some points, so you can give yourself a little t-table of points. And what I always did when I had to graph things is I chose points that were convenient for, I don't know, B. So let's see if we can't do that ourselves. Now, one convenient point would be plugging in x equals 0. If I plug in an x equals 0 here, what do I get? What do I get for y? Anyone work that
3.
out for me? Good. 0 and 3. Now, another convenient point, I don't want to put in 1 because then I have to deal with a fraction. But if you put in something that would cancel this denominator, then that might work out a little bit easier. Can anyone think of a number that I could put in for x that would help this denominator to disappear? Well, I'll help out a little bit here. What if I put in a 5 for x? You can think of that as 5 over 1 if you want to, but these cancel. That leaves me with -4 plus 3 is -1. So 5 and -1. Nothing wrong with plotting 2 points. Typically, I usually give myself a 3rd point to check things. In this case, you might want to choose 10. If you plug in a 10, then you'll get, let's see, it'd be -8 plus 5 would be -5. I'm not going to fit it on, or -2. I'm not going to try and fit it on my graph here, but actually that's not right. -8 be -8 plus 3 would be -5. -5. Yeah, that's better. I'm not going to try and graph that one here because there's just not enough room. But let me give you another way and a reminder of a couple things here. When you're working with this equation, this is in slope-intercept form, mx plus b. See, I haven't been downstairs in my basement bunker in a while, so all my pens are dry. What's the y-intercept in this graph? No one?
3.
3. So 1, 2, and 3. So we'll start here, and that means the slope is -4/5. That's your rise over the run. If you have this in mind, it can make graphing this pretty easy. A rise of 4 would be up 4, but we've got a -4, so I want to go down 4. 1, 2, 3, 4. How should I move to do the run of 5? Which way should I go?
Right.
To the right. 1, 2, 3, 4, 5. If you notice, I get the exact same points that I picked up over here, and that's fine. But this is a pretty good way to graph the equation of a line. You can count on graphing the equation of a line, not only here, but on the final exam. That's something you should leave this course with the ability to do. Now, if you want to do it the way I did it here, by plotting points, that's fine. Or if you want to use the rise over the run, so this much should be your run, and this much should be your rise, equals -4. Hey, that's fine. In fact, I might give an extra credit point if you actually did it with the rise over run and labeled it like such. That's pretty cool if you can do it that way. One way or another, expect to graph a line. That should be something you should be able to do. Now, I'm not going to be able to give you every problem on this review. There's just too many, but you should be ready for these. And if you're ready for these, you should rock on this exam. Get an A on the first one because they get harder. They don't get meaner as the semester rolls on, they just get harder. So let's take a look at this one. Now, I'll remind you of another thing that we're going to deal with, and that is the point slope form of the equational line, y minus y1 equals m times x minus x1. So that's great if you have a slope and an intercept. In fact, I'm going to kind of skip down a question or two, actually just one question, and look at that. Let me see where it is. It's in here someplace. Where did it go? All right. Well, regardless of the fact that I can't find it, let's find the equational line through this point. And these double lines here are just my shorthand notation for parallel. Parallel to this line. Well, if I'm going to use this equation, there's two things I need to know. I first of all need to know a slope. And secondly, I need to know a point. I need to know x and y coordinates. So here's my x and y coordinates. That's your x1, y1. But how do I get the slope? Well, if I want a line through this point and parallel to this one, by being parallel, that means they have the same slope. So the slope of the line that I need to use is -7/8. Now, if you're looking at that going, oh my God, we got a fraction, there's actually good news. It's not going to be so bad. If I fill this in, y minus y1, so that's y minus 0, equals m, which is -7/8, times x minus x1 should be 8, then this is actually going to simplify pretty nicely. Y minus 0 is just y. And when I distribute this, I get negative 7 over 8 times x. That's easy.
And then
Negative times a negative is
positive.
positive. And negative 7/8 times 8, well, the 8s are going to cancel, right?
So just so just a 7.
Just 7. And I'm afraid that's it. You're all done with this one. Now, if you're watching this sometime later, you're going through and reviewing this, what you might want to do with some of these problems is pause it and test yourself ahead of time rather than just watch it. So for instance, this one's done. Well, let's look back at this one, because this one kind of has an extra step involved. I've given you 2 points. I want the equation of the line between those 2 points, but you got no slope. Here, we found the slope because the line through this was parallel to this. Since that's the slope here, that told me that this line has to have the same slope. This one, they don't give me the slope, but they do give me 2 points. So we'll see if I can come up with a slope then, and I'll remind you of your slope formula. He wants to say hi, and then we're going to say bye. Forgot to shut the door. So I'll call this my x1, y1, and this is my x2, y2. The slope of a line between those is negative 17 minus 1, so subtracting this way, over 2 minus negative 2. So it gives me negative 18 over 4. And that simplifies to negative 9/2. Once you've got a slope, pick either of these points and use that slope with one of those points in this equation. So it's going to be y minus 1 equals negative 9/2 times x minus negative 2. Now, if you distribute this, let's see, that'll be negative 9/2 x. That double negative becomes a plus. Y minus 1 equals negative 9/2 x minus 9. And when you add 1 to both sides, your final answer, I apologize, I'm running out of room, is going to be y equals negative 9/2 x minus 8. Beautiful. Okay. Let me check the chat real quick. All right, Summer, following along, good, thank you. Let me go back and make sure I didn't skip a few. You should be able to evaluate things using function notation. So here's an example. G of x is this function. If you're asked to find, say, g of 2 would be 2 times 2 squared minus 2 plus 3. So 2 squared is 4 times 2 is 8. So it'll be 8 minus 2 plus 3 is 9. Nothing too big there. It's just asking that you know and understand that notation. We did these two, so we're good there. Shifting graphs. Definitely, you should be able to shift graphs. So for instance, if you're given that you know what the graph of f of x equals x squared looks like, how would you find the equation, or what would be the equation of a graph that shifts something to the left by 4, up by 7, and reflects around this should be the x-axis. We can't do the y-axis until we get to college algebra. Okay. Well, shifts left by 4, that's going to be something in the parentheses. What should I put in the parentheses to shift it left by 4? Is it going to be a minus or a plus?
A plus.
Yeah, thank you, a plus. You remember your horizontal shifts are opposite of what that sign would seem to suggest. Plus 4 is to the left by 4. How about your vertical shift? What should I do for that one?
Shifts up negative.
So minus
Negative.
7 or plus 7?
+7.
Plus 7. Your vertical shifts actually behave like you would want. Plus 7 is up 7, minus 7 would be down 7. And how am I going to reflect this around the x-axis? How am I going to flip it?
Negative in front of the x.
Negative in front of this whole binomial term. Good.
Yep.
You don't want to put it in here. That would do something much different. You want to put it out front. So perfect. Let's do things kind of a different way. And this is just a little subtle reminder that you should know what these graphs look like independent of being able to graph them on your graphing calculator or decimals. It's going to be hard for you to figure out how to graph this, what window to use, but we can figure out how it's been shifted. What's the x minus 32 going to do in terms of shifting this from the graph of the absolute value?
Shift right.
Excellent.
Right 32.
Thank you. Right by 32, up by 52. Nice. Let's use those ideas to take a look at x squared minus 8. How has this graph been shifted compared to the graph of, say, y equals x squared? How's that graph been shifted? If you're comparing these two graphs, how's this one been shifted compared to this one?
Down 8.
Down 8. Perfect. Perfect. Exactly right. So now what's the basic shape of y equals x squared? Something's been shifted down to 8, but what? What's that basic shape?
Parabola.
The parabola.
Yeah, a parabola. All right. So instead of having a vertex at 0, 0, this is going to go down to 0, -8. Now you're going to be asked for the domain and range. The domain is always -infinity to infinity, except for points that give you a 0 in the denominator or a negative underneath the square root. We want to throw out those points from our domain. None of these, none of these. Are there any places like that in this function that I could have a 0 in the denominator or a negative underneath the square root?
I'm
No.
sorry, what's
We're trying to figure out the domain of a function. The domain of a function starts out as -infinity to infinity, but you're going to throw out any points that might create a problem. Problem points would put a 0 in the denominator. Like for instance, if I had, let's see, let me do it over here, I guess. 3 over x minus 6. Then I couldn't put x equals 6 into that because 6 minus 6 would be 0. And I'd end up dividing by 0. So I'd have to throw that out of my domain. Likewise, if I had the square root of x plus 2, I'd have to make sure that x plus 2 is greater than or equal to 0 so that I don't get a negative underneath the radical. But the good news is that with polynomials in general and with this expression in particular, the domain is just everything. There's nothing that can go wrong in this function as far as the domain is concerned. So the domain is negative infinity to infinity. How about the range? The range is the y values from lowest to highest. And I am going to be a little bit particular about this one, lowest to highest. The lowest that this gets down to is -8. Somebody helped me figure that out just a little bit ago. It gets down to -8. So the y values start at -8 and go up to, well,
Infinity, right?
infinity, yeah. So -8 to infinity. Infinity and negative infinity always get parentheses. I'm going to use a bracket. Yeah, I'm going to use a bracket there on -8. Beautiful.
Can we use script R instead?
Oh, yeah. If you use script R here, that's a bonus point. Yay. I like script R. That's kind of cool. It basically stands for all the real numbers. So to review domain and range again, let's take a look at this example. First things first, is this a function? Yes or no?
No,
I got to vote for no. Do you agree? And if so, why?
it doesn't pass the vertical line test.
Perfect. Fails the vertical line test. If you draw vertical lines through this graph, most of them are going to, or a lot of them are going to intersect it twice. So it fails the vertical line test. So it's no, fails the VLT. That's what I'm looking for when I ask you a question like this on the exam. Now its domain, those are the x values that are graphed. So see, the domain is going to be from here to here. How far to the left does this go? Well, it goes to -3. How far to the right does it go? It goes up to 2. Are we including these points? Is there something that's on the graph at -3? Yes. So bracket. Up to 2, bracket again. Beautiful. That's your domain. Why don't you take a second and see if you can't figure out the range. The range is your y values. So see if you can't figure out the y values. And I want to give this one a shot that hasn't had a chance to yet today.
Would it be -8 too?
2.
Yeah, thank you. -8 to 2. Perfect. Again, with brackets. Nice. Compound inequalities. I can't say that these are my favorite problems. I believe the reason that they include these is because you are going to use these ideas in solving the absolute value inequalities that follow this section. This is 8.4 if you wanted to review things there. X is greater than -5. What kind of dot's that going to put on -5?
Hollow.
Hollow. Good. So a hollow dot, arrow to the right. And then X is less than or equal to 3. That's going to put a solid dot on 3. Which way is the arrow going to run?
To the left.
To the left. Now we want to try and find the intersection of these graphs. So that would be everything in between here. That's our intersection. You'll probably be asked to write this in interval notation. So let's think about it in interval notation. The left-hand endpoint is -5. The right-hand endpoint is 3. But try and anticipate me. Which ones get the brackets? Which ones get the parentheses?
Parentheses -5 bracket 3 or 3 bracket.
Perfect. Perfect. Thank you. Now there's a difference between the and the or. The and is always easier. It's easier to think about the intersection. The union's a little bit more of a pain. So let's take a look at this one. This time x is greater than 5, so that's going to be everything to the right. And less than or equal to 3, so solid dot here. Which way is the arrow going to run?
To the
Left.
left.
Left. Now, as far as the interval notation is concerned for this one, it'd be -infinity to 3 with a bracket, union, parentheses 5 to infinity.
Can you remind me when we would use the other sign, the union sign that's upside down?
The intersection.
Yeah, can you remind me to use that?
So I could have used it in the last problem right here. I could have said x is greater than -5, intersect x is less than or equal to 3. You're probably not going to use that in your answer.
Oh, okay, I get it.
Because what you'll do is you actually calculate that intersection and just write it like we did here, as opposed to something like this.
Mhm.
So you're probably not going to do that. One last little thing that I could give you here, though, would be the inequality you could write for that. You could write a double inequality. -5 is less than x is less than or equal to 3.
Mhm.
So that kind of implies the intersection that you were just asking about. That, okay, we're really finding the intersection of these two. Okay, so great question. Thank you so much. Let's see here. This one, you have to solve each of these inequalities separately and then look for the intersection. If you subtract 6x from both sides, you'll end up with x plus 2 is less than -2, and then subtract 2 from both sides, x is less than -4. Over here, multiply both sides by 4. So 4, now 4 times that's going to cancel out the 4 there, plus 28 is less than or equal to 20. X is less than or equal to -8. Now, the interesting thing is that you're looking for the intersection here, where they overlap. So where do they overlap? Well, let's find out. -8, -4. I've got x is less than -4, so that's going to be everything here. And then maybe I can try and do this in a different color. X is less than -8. But if you're looking for where they overlap right here. So the final answer would be is x is less than or equal to -8. Because that's where they overlap. There's no overlap between -8 and 4. It's just starting at -8. That's not the kind of problem that I give there, but if you're finishing up some of the homework there, hopefully that helps out. Or absolute value problems. You should always be looking for 2 answers. You might not find them, but you should always look for 2 answers. Before you start looking for 2 answers, get the absolute value by itself. So subtract 6 from both sides, and that gives you the absolute value of 4x minus 2 is equal to 22. And then you're going to do your positive and negative stuff. So the positive case, it'd be 4x minus 2 equals 22. That's worth 2 points. The negative case is worth 4 points.
Negative 4x plus 2.
Yeah, the negative of 4x plus 2. So what you're doing on that negative one, that negative case, is basically you're just taking this expression and putting a negative outside it in parentheses. And now you solve. 4x equals 24, so x equals 6. Here, if you distribute, you'll end up with x equals negative 5. All right. And I know I skipped a step there, but you can check me on that later. This one is kind of a little bit of a, I put that there to see if you're thinking a little bit. The absolute value of something is always positive, or at the very least it's 0. Something which is positive, can that be less than a negative 9? Can something positive be less than negative 9? Pick your favorite number.
No.
Yeah. If you pick a number like 2, 6 times 2 is 12, minus 19 is negative 7. But the absolute value of negative 7 is positive 7, and that's not less than negative 9. Nothing that you put in here is ever going to make that true. So the fancy notation is null set. There's no solution. Just doesn't have a solution there. Let's take a look at this one. And it's reminiscent of what we did up here. Up here, I said, you know what? You got to start out by getting the absolute value by itself. And that's true. What you have to do is you have to divide both sides by -1. When you do that, what special thing happens?
The sign flip.
Sign flips. You get the absolute value of 2x minus 4 is greater than 14. Now you'll set up your positive and negative cases. So again, give yourself a second. If you can, pause the video, whatever. Try and set up those positive and negative cases for yourself. The positive case is worth 2 points. The negative case, when I grade your papers, is worth 4 points. So what am I trying to do for you? Trying to give you a little incentive to get that negative case. X is greater than 9, or negative 2x plus 4 is greater than 14. Negative 2x is greater than 10. When you divide both sides by a negative, you got to flip the direction of inequality. If you solve these things correctly, you should have 2 intervals that face away from each other. X is greater than 9. That's this one. Everything to the right. X is less than -5. Everything to the left. You should have 2 intervals that face away from each other for these types of problems. For the absolute value less than case, you should have 1 interval in the middle. All right. I'm not going to be able to go through all of these. I will do the first one though. You're going to get a lot of factoring. This one is the sum of squares. So that's prime. That's nice. Here, the strategy would be to take out the GCF. That's all you can do. If you've got 4 terms, again, that should be pretty straightforward. Factor, anyone know? By
Grouping.
grouping. Yeah, one time I accidentally spelled that without the U. That was embarrassing. Find 2 numbers that multiply to 6 and add to -5. This one gets butchered a lot. It's x minus 3 and x minus 2. If this is positive, both of these have to have this sign. If you have two terms, you should be thinking about difference of squares, difference of cubes, sum of squares, and sum of cubes. 5x minus 4y and 5x plus 4y. Done. These are challenging. This is that AC method. Multiply this times this. Look for two numbers that multiply to negative 33 and add to 32. This one frustrates me because a lot of people will get this. They'll say, okay, yeah, that's going to be x minus 6 and x plus 4. Perfect. Two numbers that multiply to negative 24 and add to negative 2. And then they leave this one blank. And I really regret that. It has to start out with an x and x. One has to be negative, one has to be positive. The numbers are the same, so I need the 6 and the 4. But how do I deal with the y's? Now, so far, they look pretty identical, don't they? The y here and the y there. That's it. So I'll put these two problems next to each other on an exam. They'll be worth a total of 5 points, 3 for the first one and 2 for the second one. But get them. If you got this one, then you've got this one. You should nail it. This one, start out by factoring out a GCF, which is negative. This one is, how would you factor this one? What would you suggest I think of?
Which one are you on? I can't see.
Oh, sorry.
Difference of cubes.
Difference of cubes. So it'd be a 5a minus 3, and I'll finish this one up for you, 25a squared plus 15a plus 9. The last one factors is x plus 9 times x plus 9. On a test, if you left it like this, you'd get 2 points. If you want 3 points, then you're right, x plus 9 squared. There you go. This one's supposed to be a nice problem. And you can see that because I gave you common denominators on this. But here's what happens. People will say, okay, I'll combine these over 3x plus 21. But there's a mistake here. Does anyone see what the mistake is? You've got to distribute that negative sign.
Oh.
Yeah, I know. And unfortunately, if you make that mistake, then you're going to get about 1 point out of 4 because you're going to miss everything else. So try not to make that mistake. So in the numerator, I can combine like terms. I'll get, let's see, 2x plus 14 over 3x plus 21. You should look at this and see if there's anything more you can do, and there is. I can factor out a 2 from the numerator and a 3 from the denominator. And, oh, okay. That simplifies to 2/3. If you made a mistake and you didn't distribute that sign correctly, this would be a 10, and you would never get this. So you're going to lose a lot of points, despite how generous I might want to be in partial credit. For this one, you need to get the common denominator. That means, let's see, our LCD is going to be a plus 4 times a plus 3, which is not a plus 12. So you multiply this by a plus 3 over a plus 3, and this by a plus 4 over a plus 4. I've kind of gone over my usual allotted time, so I'm kind of hurrying up a little bit. Let's just write out.
Yeah, sorry to interrupt. I wanted to ask, is this review going to be posted online?
Yes, I will be posting this.
Okay.
Yep.
because I have to
Yeah,
go,
if-
but
yeah.
I will check it out later.
Thank you. So 2a plus 6 minus 6a minus 24, and then combine like terms. This one, you've got to do a lot of factoring first. So for instance, this numerator would factor as x minus 9 times x plus 2. And you have to factor this one and this one. When it's all said and done, there's your answer. And just to finish up a little bit, some variational problems. Solve a problem by writing a variation model. An object falls a distance s that is directly proportional to the square of time. So that means s equals k times t squared. People always forget the t, or the squared there, or they forget the k. If the object falls 784 feet in 7 seconds, so that's t is 7, s is 784, that allows you to solve for k. K is usually 16 in these problems. When you finish solving it, then they're going to ask you for one more. So, if I plug this in and solved and got k was 16, then the last thing to do is to plug in an 11 there. Here's another example of a variational problem. Question?
Yeah, I have a question. Variational problems. So when it comes to the exam and we have the word problems, can we use the sheet that reminds us what the y varies directly, the handout that you made, or should we just memorize them?
There's only 3 things really. There's directly proportional to, inversely proportional to, and jointly. So I think I'd be most comfortable if you had those memorized. It's not just me, it's a department policy college-wide that there's only a few kind of formulas that we give, so I apologize.
It's okay, I'll have it down, thank you.
All right, but it doesn't hurt to ask. All right, last little bits here. So section 9.1, you can simplify this as y minus 1 squared. And then wholly further simplify this as not just y minus 1, but the absolute value of y minus 1. Reagan, this one's your favorite. How does this one simplify? What would I write?
Narn.
Narn. This one simplifies as the square root of 4 times the square root of x squared, which is 2 absolute value of x. You should be able to calculate these on your calculator or in Desmos. That's going to be negative, which is on the outside of 5th root of that, which is 3.
Can we use this on the exam?
To use Desmos on the exam, you'd have to download Desmos test mode onto your graphing calculator or onto your phone, and then put your phone in airplane mode and stay on this app for the duration of the exam. But the answer is yes.
Okay.
Last but not least, reminder of these things. 5th root of b to the 5th would be the absolute value of b. Or excuse me, just b. This one would be the absolute value of y. Why the difference in these two? Why does this one get the absolute value and this one doesn't?
The even ones get the absolute
Because they're
values.
even.
Yeah, the even ones. Cool. All right, a little bit longer than I expected, but very, very thorough. Should leave you in good shape. Questions or comments before I call it a day here? All right.
Is Mimi still available on Sunday?
I'll let her ask that.
Just put it in the chat.
All right. So cool. Thank you, Mimi. Yeah, that's a great asset. Very nice of her to give up part of her weekend for you. So take advantage of that. But if there's no other questions, then great. Good luck.